So software-defined WAN, SD-WAN. See, the reason why we need to go into the software-defined side is our network is growing. It's not like before. Network is growing, and they want to have less number of people at the same time more effective network, more effective, less manpower, and they also want some programmers to become a network engineers. They want everyone to involve in networking, but they don't want to give job to everyone. Hence, they wanted to make it more complicated for the CLI guys who were in the industry for many years. So this is the idea behind. One is the company grows, their company grows. Whoever has deployed the software defined approach, their company, no way they go down, they go up because people want to grow, so they want to learn this new technology. Otherwise, they will not get a job. So that is a big marketing for all the companies who wants to have SD-WAN. That is the business side. Now they can sell new products. Everyone has already purchased ASR routers, Nexus routers. Now they want to make more money. Okay, let's think software defined. So if you see, every vendor has got this, not only Cisco, ACI in data center, Cisco Prime in service provider, SD Access, SD-WAN in enterprises. Like this, you have many. So this is a new revenue generating thing from the business perspective. But from the people, now software people think that okay, it's an application. Then I'm also a software guy. I can also get into networking. I can also try. Why should I compete with this software people? It's too competitive to compete with the software people. There are too many. So let us get into the networking field because network guys know only CLI. So let us also go and beat their market. Let me also go and take part in their cup of tea. So it gives an idea for software guys. It gives hope for the software developers, so they also can try this networking field. So more people come, more competition. More competition comes. It's the money for the vendors. It's a money for vendors. They're very happy now. Wow, CCIE. Not only the networking guy right, even the software guy now wants to write CCIE. Even the software guy wants to try our product. But end of the day, both are struggling. Both the software guys and CLI guys both struggle because of this challenge, the new challenge that is in the market. Why? For the network guy who is working in a networking environment for 10 years, 7 years, 15 years, 20 years, for them they have to go and learn some codings, like not only Python, there are many more. So they have to go learn those things. This is for CLI guy. This is how CLI guy thinks. Oh no, software defined. I came to the networking field thinking that I'll not be involved in programming, but now I'm forced to do after 15 years. If I want to keep my job safe, I have to now get into learning. And he struggles now in the age of like 45 plus and 50 plus to learn something new. It's not that easy. So his life is spoiled here because of the software defined. Secondly, the programming guys who tries to get into software defined, he thinks that I know coding, I can do networking, but it's funny decision. When he comes in, he knows only coding, but he don't know what to code because he don't know networking. He don't know what is label. He don't know what VLANs, and he don't know where to put what, why to put this. Nothing he knows. So very interestingly, he thinks that I will get into networking field. I don't want any software field. He throws every opportunity and he comes to networking field, thinking that he can take the food of the network guys. But both lose their food. Software guys, they come thinking like that, but they don't understand anything. They know only coding. But what to code? Where to code? Why to code? No idea. And now they say, oh, let me go back to software. Sometimes some people take risky decision. Oh, I have not anyhow learned the software proper. I simply spent my college days having fun. Now let me pay more money and learn networking so that I can understand this networking, and then I will come and do some programming. So he goes and sits in a CCNA class, wasting another 2-3 years of learning networking. By the time the SD-WAN goes old, and cloud WAN will come, and then satellite WAN will come, galaxy WAN will come, alien WAN will come, and then heaven WAN will come, and everyone will keep struggling. This is what today's software defined networking has introduced to the world, the competitive world. So, what I am telling for those networking guys, you only can do this. Software guys cannot do. Don't think that you have more competition now. No. They will just come in and they will go back very fast. So don't give hope. You can win this because you only know how MPLS works. You only know what does it mean when you say bridge to main. You only know what it means control plane and data plane. It's you the one who knows the route reflector policies. You only know BGP, you only know MPLS, you only know segment routing, you only understand VXLAN, you only can understand EVPN. So it's you the one who can do SD-WAN. So don't give up. Don't give up. Little more push. You will be on top. You are already on top because of SD-WAN. You may be feeling that you are thrown back. No. You are already in the top. It is very easy for you to understand those codings. You can just import those things in the XML sheet wherever you want to edit in a bulk. Just add those variables. You know what variable to add. For example, under the interfaces of 10 interfaces, if you want to assign same VLAN, you know what to do. You need little knowledge on that coding, not much, and you can do that. Or you can go straight away work on the GUI wizard, one by one. You may not be fast like a programmer to configure bulk. You may be following some wizard which is shown in the GUI, in the HTML page, clicking one by one. But little by little, when you get to know about those programming, you can use the programming skill to configure it faster. Means again, it is like going back to the CLI mode because the GUI mode is slow. People think that SD-WAN is going to quicken their configurations. But the real truth is After starting with SD-WAN, after starting with ACI, after starting with SD access, Cisco Prem, and so on, they end up in editing the XML sheets. And they don't use those buttons that is provided in the GUI to configure using those VIDA templates, those wizards. Initially, they start with that, and so nicely they say create a policy, create a VLAN pool, create MPLS, means layer 3 policy, layer 2 policy, all those things. So they teach nicely, click this button, click that button, click this button. But when you go to production, somehow one guy has learned Python or something like that in his college day, and he has also learned networking. And he is sitting as a boss configuring things in bulk instead of going through multiple clicks, click of a button. He just downloads and opens in an XML editing tool, and he just edits here and there and posts it. And when he posted, you see all configured, boom, like that. So these are the things that I'm seeing, which is threatening the networking guys. But I tell you, it's not too far for you to achieve. It's easy. So let's learn SD-WAN. We are not going to see the programmability side. Even I'm not good in that. I'm a CLI guy. Now SD-WAN has come, ACI has come. I started using only the GUI of it. But I have seen people playing with the scripting languages. If I do things in 5 minutes, they do it in 2 minutes. Those who have got network plus the programming knowledge. I've seen my own students doing that. Just they do it in 2 minutes, but I need to click a lot of button, wait for the next page, and it opens, and then I need to put variables, and then close it, submit it, again open another interval. It takes time. But I've seen my students just downloading, opening in an editor, tick goes and finds and replaces with a lot of variables and posting it, and then boom, finish. So it is possible. I have seen my students doing this so nicely after this training. This, what I'm saying, is applicable for not only SD-WAN, SD access, ACI, and all those things that are like uses director and so on. So with this reality that you can achieve it, you can do it, let's begin for SD-WAN. So let's not focus on this now. Let's start from here. Introduction to SD-WAN. SD-WAN is a software-defined networking for WAN. What it does is it separates the network topology from the physical device and physical links. Meaning, usually we used to have topology, the physical cabling, the VLANs, the layer 2 circuit through VLANs, switches and routers. That is how we used to have a topology. But now we are trying to separate the physical network from the data path, from the layer 2, layer 3 circuit, for which we try to create a virtual WAN overlay. If it is SD-WAN, it's a WAN overlay. WAN overlay. Basically, if you understand SD-WAN, you can understand easily ACI. You can understand easily Nexus 7500 is another example here. 7000. You might have seen some big device have written like Cisco 7000 series router. You may also, if you are not sure of Cisco 7000 routers, you can think about Nexus 7000 series or ASR 95,000, like 18 or 24, something like that, the big folks. Now, why I'm bringing those things here? They are all connected. The concepts, the architecture behind is similar, not much different. Let me go step by step. So what we are trying to do is we are trying to isolate the physical topology from the logical. We try to have a logical WAN. And underlying physical, we don't care. We just keep physical resource and wire as a resource pool. And using the software defined solution, we use those resource pool, the underlying hardware, the links, to provide us a virtual circuit, a virtual topology. So we try to separate physical topology and virtual topology, totally independent. And as I said, this is not new. This is not new. If you take any big device, let me Google it. So this picture that we got from Google, this is one of the Nexus 1000 series. And if you see here, inside this one physical box, you got two supervisor modules. These two supervisor modules are the one where we do all the configuration. But based on what the configuration is done, actions are only taken here in the line card, which is also called as IO module, input output module, the expansion module, the place where we connect our wire. See, the traffic may enter into this port and they may be living on this port. In the middle, supervisor is not coming. So the policy for the traffic to come in and go out, the routing policy, the layer 2 forwarding policy, everything resides on the ASIC, on the chip. How? Based on the configuration that you do it on the supervisor module. So it is the supervisor module in which we do all our configuration. Depending on what you configure, the chips, the chipset, the ACI, the ASIC chip, which is there on every line card. There are many chips on every line card depending on the capacity. So all those forwarding decisions, everything is made on the TCAM, on ASIC chip. So the supervisor module is just an orchestrator. They don't come in between the traffic flow, but they only decides and dictates how the traffic flow should be. They only decides how the traffic flow. They only decides which port, if traffic enters, based on the destination on which port it has to leave. These decisions are configured here, but those decisions are applied on the line cards. Now, the line cards at the back side, you will have a fabric module. Actually, they have closed it with one metal sheet here. There will be a lot of slots of fabric module. Like we have backbone, no? In our body, we have backbone. Likewise, inside you have a lot of fabric module, connecting all this at the back, connecting all of this at the back. More the fabric module you have, if I have two, let's say it is running in 2 TB speed, when I have another two, it will run on 4 TB speed. The speed will increase. So the fabric module job is to quickly take the traffic in and quickly send it out. If you have more, then more faster, more load sharing. Right, the fabric module. So if you see here, there are three things. One, the controller, the supervisor. Two, the fabric module that is connecting all this at the backside. All these are plugged into the fabric module so that they can carry the commands faster. Whatever the configuration need to be pushed from the supervisor module to the line card will be pushed faster. More fabric module, more faster. And the policies of routing, switching, all layer 4 to 7, all are applied on the port, the IO module slot. So that the supervisor module need not to come in between the traffic flow. Only when there is a new change, supervisor module will come and update. Otherwise, supervisor module will be idle. It's only the line card that is going to be forwarding the traffic. And whenever you want to do changes, you don't go to the line card. You go to the supervisor module. Through supervisor module, you configure, and the line card is get configured. Line card will get configured. Why I'm telling this story? SD-WAN is what you see here. This is not SD-WAN. This is what ACI is. This is what all those cloud concepts. This is what means when I say cloud, I mean cloud networking. This is what your SD access. So let me try to now relate this to SD-WAN. I can also relate this to ACI and so on, but today we are focusing on SD-WAN. Let me relate this to SD-WAN. So SD-WAN is not something new. SD-WAN is the bigger picture of this box. SD-WAN is broken piece of this. This is in one full form. If you break this into pieces and keep it in different place, then it becomes SD-WAN. Let's see how it is. So what happened, in SD-WAN there are some components. Like this. The control plane in Nexus supervisor module. In Nexus, this is equivalent to that supervisor module. And you see switch fabric. I said no, at the back side you have fabric. This one. Inside this. That is what there's MPLS connection, there's IP routing connection between the sites. And then between the sites, to connect between the sites, we have WAN edges. The WAN edges are like IO modules in the switch that you saw here. This is like one WAN edge. This is one WAN edge. So in Nexus, you see in one single box, we don't call it as WAN edge, we call simple IO module. To connect all this IO module and the supervisor module, you have fabric. Likewise, we have this network to connect the controller. The controllers may be in London, and the line card may be one in London, another one in Dubai, another one in Shanghai, another one in Colombo, another one in Sydney, another one in Kabul. So you have various sites. Now, how these sites are connected? Through internet or through WAN connections like MPLS, VPLS, segment routing, and so on. That is what the switch fabric is. So they made this small idea into a big idea. They have enlarged this into a big level. They applied the same approach, but in a big level. Here they make more money by selling this hardware piece, fabric and all. There you don't have fabric, instead you have a internet service provider connections. But instead of IO module, now they make money by selling WAN edge devices. Very costly. Instead of this two physical software module, let's say if the software module costs you $1 million, this hardware module costs you $1 million. Now they are selling $6 million software, VM, simple software. See how they learn to do business. Before they have to give you hardware, ship it. Now they say we'll send it through mail, don't worry. So they give you some VMs. One they call it as vManage, vBond, vSmart. So instead of selling the supervisor module, now they are selling some softwares that you need to run on some VMware environment or anywhere. It's a software, but the price is big. Why they made the price like this? Because this is an application. You don't need to learn those commands that you learn in your data center or in your MPLS enterprises, BGP class, the service provider class. You can just simply use the software to manage and deploy not just one box, it's the entire big world network. So they can easily make money because it's going to support a big picture now. That's why they charge you 6 times more than the hardware. But for them, it's a big advantage, big gain. With nothing, they make big money. Just the same software, they sell it to many, and they embed those serial numbers of the V edges, and they connect to the cloud now for authentication purpose. Those are the extra service they provide. They make that big money. So one part of SD-WAN I have explained you. So SD-WAN is not new, it is there for many years, but it is made bigger now. Earlier the name was Nexus 7000, ASR router, and so on. The idea, the architecture is same, but now it is spread across the world into small pieces. Next is about the SD-WAN. As I said earlier, we now bind the application to the overlay path. Earlier we used to bind the application to the MPLS, to the IP network, internet, to the LTE network, to the layer 2 policy, switching policy. But now we are least bothered about this hardware. We are least bothered about these layer 2, layer 3 technology. We simply bind the application to the overlay. But there is definitely a big advantage. I should not say SD-WAN in the negative side. SD-WAN has got a good positive side because it is being driven by software, because it can see a bigger picture than a human being can see. It can provide you a less latency, the full mesh topology. For us to achieve this, maybe in a small network we can achieve this, but as the network becomes bigger and bigger and bigger, the latency, controlling the latency is very difficult. We need to put QoS, MPLS, COS, traffic engineering, QoS, sometimes segment routing with QoS and many more. That is really a lot to do. So we don't now bind it to this, our policy. We just bind the application to the overlay tunnels. Overlay tunnel is basically using these technology at the underlay, but you don't see it. You just got an MPLS connection, you got an internet connection or LTE connection or normal layer 2 switching or MPLS layer 2 VPLS. The overlay will make use of all this technology and it can do load sharing. Okay, when one application comes, it will check whether MPLS have got enough bandwidth. No? Then it will try to check whether internet has got enough bandwidth. If internet has got that bandwidth and if it can take to the destination, then it will use the internet automatically. The overlay path will be based on the internet connection. When internet connection get congested, then it will check whether MPLS have got or LTE has got, and it will push according to the availability. But later that is not the case. We used to say, if you would have done MPLS traffic engineering, you may understand what I'm trying to say. We used to go under the tunnel interface and we say path option 1. Check this path. If that path is busy, then use the second path option. If that is also busy, use the third path option. Now, we give like this many options. Manually, we do everything. We take everything on our shoulder. But here, the software is ready to do all those analytical work. All that we need to do is we need to tell to the software what we need. We just tell to the software, this is what my expectation for the voice application. This is what my expectation for the backup traffic. For everything we say, this is what my expectation is. According to the expectation, software-defined networking will decide whether to send it via MPLS or via internet or via LTE connection. So it's been taken care. That's one way of doing SD-WAN. The other way is you manually binding, okay, voice application. I want only MPLS path. So there's something called TLOG, transport locator, which is mapping the gateway of the MPLS tunnel. We'll talk about the TLOG later. I do not want to get into those technical deep dive so early, it's too early. So far what I have seen, shown to you is SD-WAN is separation of physical and virtual. Everything that you want, you just talk to the virtual overlay, based on which the underlay will be determined. Underlay topology will be determined. Secondly, I also tried showing you that SD-WAN is a bigger picture of ASR, bigger picture of Nexus 7000. So the components of this Nexus 7000 or ASR is distributed now across the globe, kept in various sites. And as I said, the internet is used, the WAN connections are used as a fabric of the Nexus switch. WAN edge is a device where we see on every site a special switch called WAN edge. This WAN edge is like an IO module in the Nexus switch. And we got a supervisor module to manage all this, to configure and manage. And now here we call it as those control plane here we called as controllers. There we called as supervisor module. Here we called as SD-WAN controller or SD-WAN control plane or SD-WAN orchestrator. All right. So actually this is of three components, as I said earlier. We manage, we smart, we bond. Yep. So these three together is what we call as controller. But remember, these are only virtual devices. The only hardware device we have is WAN edge. But even the WAN edge is also a virtual software. Cisco Cloud 1000 or C1000 device can also be used as a WAN edge C1000V. So the basic main components of SD-WAN is vManage, vSmart, vBond, vEdge. Right, so these are the main components in which this is what called as SD-WAN control plane, which is equivalent to control plane module in Nexus, like supervisor module. vEdge is seen on every site edge. vEdge is now called as WAN edge actually. WAN edge. It is simply a line card on the IO module with the ASIC. And now the connection between the controller and the IO module is usually through the fabric, but here for our fabric we are using the WAN connections, internet connections, MPLS connections. So far good. Did you understand this part? Now, if you don't mind, shall we stop here? Because at 4 o'clock I need to send one important mail. All right, we'll continue this tomorrow. All right. So far whatever I have spoken, was it informative for you? You liked it? Okay.